Mr. Clown here. We're going to be doing today the volume of cubes and cuboids, the volume of a prism. Now, if this is your first time here, please remember to subscribe to this channel and give this video a thumbs up if it's been helpful for you. Also remember to turn on the notifications by clicking the bell. Let's get straight into it right here, right now with the volume of a cuboid. A prism is a 3D shape with the same cross-section area all the way through. Some examples, a cuboid and a triangular-based prism. If you look at a cuboid, for example, the cross-sectional area you can see going all the way through the shape in purple there. Also, if you look at a triangular-based prism, you can see the same thing with a triangle going all the way through the shape. There's the length of the cross-sectional area, there's the breadth, and then there's the vertical height. Remember, I've just showed you that if I take this cuboid and flip it around, you should be able to see here that that's the height of the shape. So that's why it's called the vertical height. It's the length which is at right angles to the cross-sectional area that I'm going to use. So the first step for calculating the volume of a cuboid or any prism is to work out the area of the cross-section. So the volume of any cuboid or any prism, the volume equals the area of the cross-section times the vertical height. Now in this case, the cross section is just a cube or a cuboid, depending on the example. So the area equals the length times the breadth, which means the volume of a cuboid equals the length times the breadth times the height. Now we could just remember length times breadth times height, and that would be a fine thing to do. However, it means we would then have to remember a new formula when it's a triangular prism, a new formula when it's a cylinder, a new formula when it's something else. And we're not really understanding what we're doing just by plugging in numbers. So instead, we're going to remember that we need to find the area of the cross section first, and always times the vertical height. So the formula I'm really going to use is volume equals area times height. That's what I'm going to remember. Area of the cross section times the height. Just a little note before we move on. If I label this side here the vertical height, the reason I'm going to do that is because if I can rotate this shape, really the height of the shape is how tall it is. And you can see here that that's just the height now as well. Okay, example 1 says, calculate the volume of this cuboid. So step 1 is always to recognise what my area is. So step 1 is the volume equals area times height. So I need to work out this area. So I draw a little picture for myself. I've got 2 here and 4 here. So the area is just 2 times 4, which is 8 centimetres squared. Now we move on to step 2. Step 2, volume equals area times height. So I take my 8 and times by my height of 10. Remember, this length here is my vertical height h, and that's 80. A note on units, the units are cubic centimetres. A length has a normal unit of centimetres, area is square centimetres, and volume is always cubic centimetres or cubic metres, cubic units, okay? Okay, let's do example 2. It says calculate the volume of this cuboid. So we start the same way as the previous example. I identify my cross-sectional area, and I need to identify the dimensions, the lengths. Now, in this example, it's deliberately difficult, okay? So we need to actually look, 5's here, so there's 5 at the front there. So I've got 5 centimetres. And then if you look, there's a 6 here, so translating that to the front of the shape, 6 is on the side, so I've got 6 centimetres. So the area of the cross section is just 5 times 6, which is 30 square centimetres. So then moving on to step 2, the same method as always, we want to work out the volume. So volume equals the area of the cross section times the vertical height. So I've got 30 times, and I better check what my vertical height is. There's my height here, that's the length of the shape in relation to the cross section. 30 times 12 which is 360, and again, cubic centimetres. It says, this is a special case I suppose, because it says calculate the volume of this cube. A cube is just a cuboid. It's still a cuboid, except all the faces are square. So every single face is a square, instead of some faces being rectangles and some faces being squares, okay? Or all faces being rectangles. We still tackle it the same way. We identify our cross section, but in this case our cross section is 7. Since all sides in a square are the same size, it is 7 by 7. So the area is just 7 times 7, which is 49 centimetres squared. The volume is the area times the vertical height. You'll notice there's not any other numbers on this example because all the sides are 7. So the vertical height is also 7. So it's 49 times 7. 7 times 49 is 343 centimetres cubed. So that's a special case for a cube where you're only given one side because one side is the same as all the sides. Technically what you could do is just cube 7. 7 times 7. Mr. Cleon here from Cleon Maths. Thanks for watching. Please remember to like and subscribe, and also check the links in the description for extra practice on any of these topics that we've just covered. Thank you very much for watching.